But yeah, it'll look a lot like your homeworks do. It'll just be timed, which adds some stress to it, I know. But it'll have, 11 or 12 questions. You'll get one shot per question. So it does make it a little bit more, intimidating, I suspect. But the nice thing is the format will be very much the same as what these questions look like. I'm actually grabbing some of these from from what I made the test out of. So.
Do we get our scores immediately or no?
What's that?
Our scores.
On the test?
Yeah, right after it's done.
Yes, you'll see the scores right after it's done. It won't show you what the correct answers were until after the test closes. But it'll show you the score. But there is there is a second part to that we'll talk about before we're done today. So this is like many of the questions you'll see on the homework and on the things like the test. So take just a moment. This one's given to you in a table as opposed to a stem and leaf plot, but it's asking similar types of questions. So we want to find that interquartile range, the sample standard deviation. Notice this one is even helping us by telling us it wants this to be treated as a sample, as we will all of ours for right now. The 1.5 IQR rule, we talked about that last week. So it's asking to find those specific cutoffs and then identify outliers, and then use the standard deviation rule. As we talked about, this should really, instead of saying outliers, should say unusual data. But finding those cutoffs for that unusual data. And then, are there any unusual? Well, I'm going to say values. And if so, what they are. This isn't asking what they are, but we'll find them. So take a moment, find that IQR in whatever method you would prefer.
Can you zoom that a little?
Probably. Yeah. Is that better?
Yes.
Cool. Again, we can use the calculator, we can use Excel. We'll go ahead and do this one on the calculator or together just for once I give you guys some time, but we'll do it with the calculator just to give us the contrast. I'd say usually for me, putting the data into the calculator is the most irritating part. But I, of course, messed up 2 of the numbers typing it into Excel, so. So maybe I shouldn't talk.
Now the IQR is
Interquartile range. So that would be your third quartile minus your first quartile.
in order to find the center, correct?
In order to find the spread of the center, yeah. That interquartile range is a sense of spread. It's kind of like standard deviation, but for position. Yeah, typing this into a calculator that is on a computer is just a weird thing to do. I'll show you my calculator emulator thing here in a minute. Actually, I could probably just do that. And then you guys can see both, can't you? Whoop, I was 13.7. And then 15.7. So 19.1, 17.7, 18.6. Oh, that 38.2 is big. Okay, so I think that's all typed in correctly. And really the nice thing, the nice thing we get for having all that work to type it all in is the one variable statistics tool is nice that it gives us a whole bunch of information all at once. We do have to make sure we know what all of this information is. So we do have our mean there, the X bar. It is finding that sum of all the digits in case we need that. We don't, but if we were using that for anything, we'd have it. The standard deviation, though, is right here. There are two of them. Nick, this kind of gets to what you were saying. We have the standard deviation as a sample with the S, and a standard deviation for the population with the Greek sigma. They're essentially both an S. This is just the Roman S versus the Greek S. But the Roman letters, the normal, what we think of as normal letters we use for samples, the Greek letters we use for parameters, for population data. So this essentially, the 5.1 is the standard deviation sample. The 5.0, a little bit smaller, is the standard deviation P for the population. So that's should be the same values if you use them on Excel. So the 5.152, that's our sample standard deviation. And I didn't actually remember what it was. So 5.15. So down here, 5.15. Anybody get that same value? Just to make sure I typed everything in okay. Allie, you did? IQR, let's see. The IQR, we can go down here, it gives us the minimum, the Q1 median, which is our Q2, our Q3, and our max. So our interquartile range will be the difference between those two. So 19.55 minus 15.4 4.45. Alan, you're saying is 4.1. Yeah, I buy that. thing I like about Excel is I can just make Excel calculate it, but that subtraction isn't too horrible. Anybody want to back us up on that one? Allie? Okay, good. So yeah, the benefit of the calculator is it does give us all this information all at once, which is really handy. If you use that data analysis tool for your last lab, then that also gives us a bunch of information all at once, kind of an overwhelming amount of information, I always felt. So either tool that you're using at this point is fine. Do try to learn how to use both tools because they both have advantages and disadvantages. But kind of pick one that you want to get really good at so you can be comfortable with it. Okay.
Is there
Go ahead.
is there any reason why like you would get the wrong values even if like you double checked it, you put the values in right? Like if it comes back and like your standard deviation.
Well, what did you
wrong,
get for
so-
your sum? Do you remember? Or do you have it there?
Yeah, I got this. I don't know if you can see it.
I can't. What does it say for the sum? The third one or the second one?
It's $7.99.
Yeah, notice on the problem, it says checksum 367.2. The reason it's giving us
Yeah.
that checksum is so we can check to make sure it's typed in right. So if you're
Yeah,
not getting that checksum, there's some number in there that's wrong.
Could be a decimal point.
Yeah,
it must be a lot of numbers because it's like way over that. It's like
yeah, being as over that as it is, looking for that decimal is probably a good thing
yeah.
to look for. But yeah, that's, if you notice, it gives us that sum. That's so we can check. Even in Excel, we could do that same thing. You guys can see the whole screen now. So like if I highlight this data, it says what the sum is down here. This is for the other data, of course. It just allows us to very quickly compare to make sure, okay, are we looking at the same data set? So there's got to be some number in there that's off. And it's just, again, it's one of the reasons I actually don't like the calculator as much. It's harder to find those errors and it's harder to edit them. But I might just think that because I'm comfortable with Excel. So, but I think once you're comfortable with both, it's easier to manipulate if you're in Excel. But it does take more learning. So you'll find
If
it
the
there.
numbers are right and you confirm the numbers, then it's got to be in the decimals.
Yeah, if all the
I don't
digits
know
are right.
what's wrong.
One of the things that I've often found to be true is if you're in that situation where you just can't find it, but you know the data set has to be wrong because that sum is wrong, trying to find it can sometimes take longer than delete that data set, put in the new one. Just put it in again. Just delete the whole thing, put it in again. Sometimes that's a lot faster than trying to hunt down where's my decimal point off.
Yeah. Sorry, we can move on. We'll have to wait.
So that 1.5 IQR rule, it's not telling us how to find it. It's just referencing that rule. So how does that rule work? So if we imagine we have a box plot for this data, you remember that box plot has its middle at our median, our Q2, its ends of the boxes at Q1, Q3, and then our minimum, often called Q sub 0, and the maximum Q4. But if we want to find what those potential outliers are, we find them by taking the outer quartile, so the value for Q3, and we add 1.5 times that interquartile range to get an upper cutoff. And then from Q1, we subtract that same 1.5 interquartile range. We have to be careful. It's very common, and this might have been what you had done, Olivia, for that 22. It's often common to want to add and subtract them to the median, to that Q2. But we've got to add them to the Q3 and subtract them from the Q1. So our Q3, well, I don't know what my Q3 is, but it is on the calculator. Our Q3 was the 19.55. So the 19.55 plus the 1.5 times the interquartile range, which, Alan, you said was 4.1. So we can find that value. And then our first quartile was 15.45. So 15.45 minus 1.5 times the interquartile range. So those will give us the lower and upper cutoffs that we're looking for. So take a moment and crunch out those values. Should be about what, 25-ish and 9-ish. A little more accurate than ish would probably be good.
Yeah, I think I added instead of subtracted for that,
That makes sense.
but I got it.
Cool. I always think for interquartile range, you've heard me say this a couple of times and you'll continue to. I think for things like interquartile range, especially about any of these, drawing out this little diagram, what am I actually looking at, helps a lot. Because if you did this and then got, like, say this was, I forgot what it was on yours, but you know, for us, this is 15.45. If you made the mistake to add it, you'll get something bigger than that and you'll see it. Does that make sense? So drawing it out so you know, okay, I got to have a number down here, so it better be lower. Oh, I added instead of subtracted. Having that visual reference there can be really helpful. So anytime you can draw yourself a little diagram, bring in that visual cortex, can be really, really helpful. Anybody get the lower cutoff?
I got 9.3.
I got the same.
Go. What was that again?
9.3.
9.3. Okay, that seems reasonable. It's down here, 9.3. So 9.3. Well, what about this upper?
25.7.
25.7. 25.7. So anything above 25.7 or less than 9.3, we'd consider an outlier. So are there any outliers?
Nope.
There's one because you have a 38.2.
Yeah, that 38.2. And one of the ways we could check that is if you look at the calculator says the max is 38.2. So there's something more than that cutoff in there. It should really be recalculating that max based on that, but it's not going to do that because it's a calculator. So we do have that 38.2. Is there anything else bigger than 25? There were some that were close, weren't there? No, really. Most of them are at the 20. So yes, the 38.2. Is there anything lower than 9? I didn't see anything that was even lower than 10. Okay, so just the 38.2. And really we're asked yes, so yes would be fine, but it's nice to tell people stuff. Now, the 2 standard deviation rule is another way to talk about, again, talk about outliers. It's not the way we want to think about outliers in a technical sense, but so I'm going to stick with that language unusual. But it is something that, and I'll check on your tests, make sure your test does unusual as well. I can change that in those questions if it's wrong or if it's you done this way. But that other way to talk about outliers is to use those 2 standard deviations, because we know 95% of our data should be within those 2 standard deviations, at least if it's nice and normally distributed. So again, I'm going to recommend that we always try to visualize these, particularly when we get to chapter 7 and start making things a little crazy on these diagrams. Having the drawings really going to help. We don't know what the center of that is, I suppose. We'd have to go find it, but luckily, again, we've got all the data we would need. So 18.36 is our mean. So a mean of 18.36. And our standard deviation was our, what, 5.15? I think that's one of the things that makes this question almost a little bit tough, is that, or actually tough, is that it asks us for the interquartile range, and then to find these cutoffs, we need to go back and find that Q1 and Q2. So it didn't tell us to find the Q1 and Q3, sorry. It didn't ask us to find the interquartiles, but it did require us to use them. Same thing here. We need that 5.15 for our standard deviation, but to find our cutoffs, we need to know that mean of 18.36. So it's almost kind of like, well, how am I supposed to do that? I don't have the information. Then go find it. So I think that could easily throw somebody off on this question. Of course, for the unusual, we need 2 standard deviations. So we're going to be adding that and subtracting it twice. So we're going to get the 18.36. We're going to add and subtract 2 of those standard deviations. So 18.36 plus or minus, what, 10.3? If you multiply those together, so was that 28.66 and 8.06? You can correct me if those are off. Those off?
Yeah, that's fine.
All right. So our lower cutoff, 8.06, our upper cutoff, 28.66. And notice these numbers are different. They should be. They're using different rules. For by default, if we talk in here about outliers, we mean this 1.5 interquartile range. That's what we are going to use outliers. This 2 standard deviations, that's usual or unusual. Inside that's our usual data, outside that's our unusual data, just to keep them straight. So according to that data, is there any data up in our set that's unusual? Yes, and it's still that same 38.2 is unusual.
You awake, Allie?
No, it's Monday. I worked late last night, so I'm
Mhm.
like,
Oh,
You're
something.
usually at work when you're in here, aren't you? Your background is different.
I know I feel like I'm different every time I'm in class.
Oh, one thing to keep in mind for the rest of you, Nick, Leslie, you, Yvonne, Tessa, if you're worried about the recordings, if you've watched some of those recordings, the people who are not the host, so everybody other than me, you don't show up in uh, those recordings. I know I had some people that I was saying, hey, why don't you guys turn your cameras on? And they look like, I don't want to be recorded and be on YouTube. It doesn't record you guys. Fair?
I ain't afraid of being on no camera.
Well, that might not be the reason why. I just wanted to throw that out there.
Bring it.
Bring it. Okay. Let's see. So let's look at a smaller version, kind of a different version of a similar question. So these aren't happy. So we'll kind of, okay. Why? Oh, that's why. So these aren't happy. So let's kind of take what we have found and see if we can imply it to this. This is in some ways giving us a lot less information, but a lot more pointed information. We're given the 5-number summary. So we're told this is our minimum non-outlier, our maximum non-outlier, and we're told our Q1, Q2, our median, and our Q3. So we know those. I don't know if those arrows help at all. So we know our quartiles. Again, we often call that one Q0 to 0. And this one Q4. So we're asked to, find what the cutoffs are for outliers again. And of course, outliers should be that Q1 minus the 1.5 interquartile range and Q3 plus the 1.5 interquartile range. And the nice thing is with the 5-number summary, we're given everything we need to be able to find that because we have the Q1 and Q3, so we can find the interquartile range or equals the Q3 minus Q1, so 15 minus 1 is 14. So that's our interquartile range. So that's these. And the Q1 is the 1 and the Q3 is the 15. So 1 minus 1.5 times 14 and 15 plus 1.5.
So you just eliminated the 0 altogether in the number?
I didn't eliminate it. I just didn't use it because our interquartile range is, that's why it's the inner quartiles. The inner quartiles wants to know how much is in this inside part. So the 0 and the 18 don't affect what we call outliers and what we don't call outliers. They're not, it's not that we're throwing them out. They just don't have a reference in this question. Even that 13 doesn't affect what is or isn't considered to be an outlier. So we could literally have only been told Q1 and Q3 and we'd still be able to do this question.
Well, with the information as far as the data summary, I got totally different results.
What did you do with them?
I typed them in.
Well, I mean, how did you, well, I mean, what did you do with the 5-number summary to get those answers?
Oh, I put it in the plot thing, and then
Right. So this isn't your raw data. Your raw data, this is the 5-number summary. This is already descriptive statistics. So on that last question, we had all of this data, right? And we used that data to find what the Q1, Q2, Q3 were. This question is saying, okay, I've already found the Q0, Q1, median, Q3, and Q4. I've already found those. Using those, tell me what my IQR are and my cutoffs are. We're not being asked to treat this as a new set of raw data. So the fact that it's a summary of a different data set is the key there for that interpretation. And if you'd have seen it written out, our min equaling 0, 0, our Q1 equaling 1, our Q2 or median equaling 13. If you'd have seen it written out like that, it probably would have.
so yeah, that would have changed things.
Yeah, that's essentially what it's saying, because that's what the 5-number summary is. It was just not labeling it with as much oomph.
Well, I don't like it like that. You need to revise it so that we don't have to see it like.
And I don't think I have to, because we should know what a 5-number summary is.
Well, until about 5 seconds ago, I didn't.
So it's been a good 5 seconds.
It has. I feel much smarter.
Good. So 1 minus the 1.5 times 14 is 21. 15 plus 1.5 times 14 is 21. So negative 20 and 36. So an observation is considered an outlier if it is below negative 20. And it's considered an outlier if it's above 36. So if this data set contains anything that is below 20, those would be outliers. Now, oftentimes people say, yeah, but we're told the minimum is 0. You're told the minimum non-outlier is 0. So there certainly could be a handful of points way down in those negatives. We're told the maximum non-outlier is 18. There could be points out here above 36. You always have to remember from this 5-number summary, the 0 and the 18 are not our extreme data points. They're not our highest and lowest. They're our min and max non-outlier. That often throws people off. They want the max to be the max. Of course you want the max to be the max. But in the 5-number summary, it means something slightly different. Which is frankly why we often like to call them Q0 and Q4, because that doesn't bring that min and max idea in there as much. Let's see. What else do we have here? You guys have any questions that you want to throw out while I'm looking for another one to look at?
Yeah, so with everything that's going on, how much are the quizzes actually, or the tests actually going to cost us on our grade?
Cost you? How much is it going to earn you? It's in your syllabus. It's, I think, at least 25% or so. Not each, but like all together. So it's a fair chunk. It's not as much as it usually is, but it's still a fair good chunk.
Okay, what about the lab?
The labs, I think they're 15. Speaking of labs, and you asked about labs, um, I've been sick all weekend, and I'm still actually pretty sick. So I'm a little bit behind, not a little bit, I'm a lot behind on those. But I did check, and I do have them. Those of you who sent me little notes about asking about them, I do have them. They take a while to go through, and I'm still working on those. So I have them, and I don't plan to do anything else today, but try to get caught up on those after my classes. So and I know it's been worrisome, so I do apologize for that. So yes, Alan, the tests are worth a fair chunk. But the nice thing is, if you've been practicing with the homework since the test, I am grabbing, like this is just off of the, about to paste here, is off of some of the things that I used to build the test questions. So, the reason why this one says question 1 or attempt 1 of 1 is because it's a test question. You will not need to take it at a specific time tomorrow, but you will need to take it tomorrow. A couple of differences from the homework. You can move between questions, but as soon as you submit it, you can't mess with it. So you can go ahead and work like question 1 and then work question 2 and then go back to question 1, as long as you don't submit in between. When time runs out, it will submit all of them, all at once. You're very welcome. Also, as I said, the test will be timed. It gives you an hour, so you will be able to go in and have it scaled. So hopefully that time limit won't be too serious, but do be careful with it, because if you are spending a lot of time on a couple of questions, you could run a little short on time. I actually might make it a little bit longer time frame. I'll play with it. Also, as soon as you start it, you have to see it all the way through. Yes, the test, it's on my version of the calendar. It's hidden from you right now, but yes, I can update that. That's a good note. So you guys can see it. I want you to be able to see. It's on the top of the page now. It was on the bottom of the page, but you should be able to see it at the top of the page now. How many questions? I think about 12. I'm messing with it a little bit, but usually around 12. Does that go for written questions too? Yes, that goes for written questions too. I've got about half of those done. So yours might not be done yet, but I got about half of those done. I will try to make sure the time is relatively comfortable. You got to be careful, because if I make it too long, then I'm like, oh well, I can add a couple of questions, and then it can get problematic. Can we use a late pass on lab 2? See, we started lab 2 Thursday. Were you here on Thursday, Nick? No, so that might be why you're why not. Yes, you can. You should be able to. If you can't, let me know. If it stops you, let me know. It's a pretty short lab. I think most of the people finished it in, during the time we had together. And you can look at the recording from Thursday if you have questions on it. Okay. So real quick, if you've been following with that, do make sure you find this z-score. I want to make sure we talk about also what a z-score means, because you will have questions on your test, a couple of them that do make you write things out. Do note it won't give you points for those until I go through and check them. So don't let, if it says, no, you're wrong, don't let that bother you. I have to go in and check them. So real quick, I know you guys have to go. What is a z-score? A z-score is the number of standard deviations a value is, oops, from the mean. Usually, how far is a value off from the mean in terms of standard deviations? We had an example that we looked at with, I think it was test scores. Z-scores helps show everything in how far it's spread within its own metric, within its own environment. So if we want to find the z-score for this particular value of 195, 195 is a particular score. So what is the z-score for that raw score of 195? So our z-score, we have a nice formula if we want it. It's the difference between the value and the mean. So that's how far off we are from the mean. Notice we're subtracting it from the mean, or subtracting the mean from it. So if this x value is less than the mean, it's going to be a negative result. That tells us our z-score will be negative, and the negative says you're below the mean. If the x value is greater than the mean, the result's going to be positive. So positive z-scores above the mean. We want to take that difference and find out how many standard deviations from the mean it is. So how many S's it is from the mean. So we're going to divide it into that. So 195, that's our value, minus the mean of 145, divided by the standard deviation of 20. That's going to give us, what, 50 divided by 20, which is 2.5. Seems like a lot. No, it is a lot, but that's okay. So a z-score of 2.5 says you are 2.5 standard deviations from the mean. Is 2.5 standard deviations from the mean, is that a lot from the mean? Is that not too much from the mean? What do we think of as 2.5 standard deviations? Is that way out? Is that pretty close? How would you interpret a z-score of 2.5? Let's see how anybody responds to that.
Isn't 2 deviations all we're supposed to go, and then everything beyond 2 deviations is outlier?
Everything outside 2 standard deviations is considered unusual. Outlier, we use the 1.5 IQR. We really shouldn't have to go more than 3 standard deviations. So remember, for standard deviations, 1 standard deviation was 68%. 2 standard deviations was our usual data, was our 95%. and 3 was almost all our data, almost all, or 99.7% should be within 3 standard deviations. So 2.5 standard deviations above the mean, that's a lot. So 195 is unusual. And I'm going to say unusually high because it is positive, and so it is above the mean. So that 2.5, that's a big standard, that's a big Z-score. If you got a test, if this was a test where you wanted high scores, that 2.5 standard deviations above the mean would be a really high score. Questions about it? Any of that? You could get a question like this back that's reversed, by the way. You could be told, you could be told your mean and your standard deviation and given this 2.5 and then asked to calculate what the score was. You could be given the score, the Z-score, and the mean and solve for the standard deviation. You could essentially be given any 3 of those pieces of information and have to find the missing one. With a little bit of algebra.
Yeah.
A little bit of algebra. Okay. Tomorrow, I'm basically going to be hanging around. If tomorrow I tried to start you on your probability section with your test being tomorrow, I probably wouldn't have a lot of your attention. So my plan tomorrow is to be here with some sample questions like these and answer your questions that you have, anything that came up as you were trying to go through the sample that's on MyOpenMath or playing with your homework, or if you had any questions on your labs, just trying to get anything else answered. If you want to take the test during our time here, you're welcome to do that. If you don't have any questions and you're comfortable. If not, I'm just going to be here to try to help.
Is that review study guide still on MyOpenMath?
It should be. If you can't see it, let me know.
Okay, I'm gonna check right now.
Okay.
And anyone with special needs is allowed extra time, yes?
Yes, that's in the system.
Perfect.
I added that. If you notice that it's not, I can actually check right now. Since you brought it up.
It's there under week 3.
Okay. Yep. Anybody with students services stuff, it is accommodated. It is in there.
Perfect.
Anything else?
No, sir. Thank you very much.
Sure. If something comes up, let me know.
All right. Thank you.
Sure.
Get well.
Oh, I will. Thank you.